her. Okay.
If I get to her first, Mom.
So, yeah, I was telling Nicole, I just spent the last 45 minutes on a Zoom with Sister Lemon. She was helping me because I couldn't even function through 16. Like, I haven't done the homework for 16 yet. So I haven't really looked at anything for 17 yet because I didn't feel like I had a good handle on 16, and I figure one just builds on the other. So
right.
I'm basically useless this evening, so I apologize for that. And then our, we're down 2 people, so
yeah,
it's all about you guys. I'll run the program. It's all about you guys.
Well, definitely don't feel bad, because I started the quiz about an hour ago, and I thought it was very easy. And I'll be more than happy to share my thoughts on it. And I think Nikki's probably doing fine as well, correct?
We'll see. I did the homework for it, and I understood the math portion of it, but I missed 2. It's like when they do like the word problems with the word answers where I get a little bit lost on it, like the confidence and yeah.
Right. And you know what? That was my problem on the last exam as well. Yeah. It just seemed like it took so long to figure out, all that stuff.
Mm-hmm.
And I ended up guessing on most of them, and I did very well with guesses. It's just it kind of makes my head hurt.
Yeah.
And that's very frustrating. It's the new math.
Yeah. Oh.
So, okay. So number 3, the symbol for the true population proportion following. So I'm saying population proportion, so I'm thinking it's the middle one, but it confuses me then when it says true. But if we're talking population proportion, it's the p hat one, correct?
That is correct. I am certain.
Yeah.
Okay. So for the next 2 questions, suppose n is 100, p is 0.25, and the p hat is 0.10.
Let me tell you something before you do that question. I just sent an email, and even though I am a huge fan of my calculator, I did put that formula on an Excel spreadsheet that I just emailed. So okay. It should have come through. If you want to pull it up, that one's on the one that says formulas and calculators.
Okay, I haven't gotten it yet. But
you haven't?
No, me neither.
Which one did you send it through? Did you do Gmail or through the school?
Gmail. Although, you know what?
I haven't gotten it yet.
It says it's stuck as draft. Oh, I should hit send. Now, I know you're going to laugh at me, but honest to goodness truth, I have a very technical job, but stuff that's technical on my desk and with my phone, for some reason, I am not very good.
Oh man.
So hey, Nikki, do you do gymnastics that you're crazy for flips?
Yeah, I did it all growing up.
Oh.
All the way through high school, I did that and cheer. So.
Okay.
Yeah.
Gymnastics is pretty darn awesome. And you did ballet probably also, right, Nikki?
No, they had you take like dance classes in it, but never did ballet or anything. I loved it though.
Yeah.
So Ed, there's 2 here. It's 3 of 4 and 4 of 4. Is there a?
Well, see. Yeah, open both of them. The 1 and 2, or just the QDS and the QIP that we used in Unit 1, and this 3 and 4. Actually, open them both up, I guess, because we'll be using them both for this answer.
Okay, so 1 second. So we're using 3 of 4 on this one?
Yeah, let's go ahead and use 3 of 4.
Okay.
So as you're looking at, Nikki, do you have 4 QDA underscore hat open? Oh, Nikki probably has to break off to.
Yep. Take care of the baby.
Yeah.
Yep.
Okay. Well, good. Then, Joan, it's open. For this question 4, says the requirement. Oh, for the next 2 questions, suppose N is 100, P a quarter, and P hat a tenth. So at the bottom of the QDA underscore hat file, I added that formula towards the bottom. It's row 22-ish, I think. And it also has a screenshot of the actual formula, not just the the cells doing the work. Even though I think we're allowed to use Excel for the rest of the course, from what I told.
Yes, we are.
I love my calculator because I've used it for 35 years.
Yeah, I know, but as you saw the other night, I can't use a calculator.
No, exactly. No, and that is part of the problem, and I feel that problem too, even though I'm comfortable with it.
All right. So for the next 2 questions, suppose N is 100, P is 0.25, and P hat is 0.10. The requirements for constructing a confidence interval are satisfied. And I don't even know what that means because, as I said, I didn't even read chapter 17 yet. So what are the requirements for? Let me see what the requirements are for. I'm assuming it's the same. Is that the 1 minus? Is it the same? The 1 minus?
Actually, you know what I just said about row 20? Scratch that. This question, I think, is just referring to what shows up in row 7 or cell E7 and F7. So I think if you input.
Okay, so it says, like other procedures, there are requirements that must be checked in order for the confidence to be valid. The confidence intervals are valid when NP hat is greater than 10 and 1 minus P hat is greater than or equal to 10. So it's the same thing, right?
Right.
We're looking at so I have to go back to what I was just doing with Sister Lemon. So if P is less than a half, this is what she just told me. If P is less than a half, you're only interested in the, you really only have to figure out the first one.
Yeah. Yeah, in fact, you know what?
That is NP hat greater than 10.
Yeah, it's easier on the one that says 404 formulas and calculators, Excel. I'm looking at that right now.
Okay.
If you open that one and go to about cell 119. Or cell 123.
All right, I'm just saving it first and then I'll look at it. So cell 123, okay.
Okay, so the N is 100. So if you do cell C123 and you put in 100 there.
And the P hat is 0.25?
Yeah, well, in this one.
What does it say?
Yeah, for a confidence interval, it's P hat. And I think for the other one, it's just P. Does that sound right?
All right, so N is 100, P is 0.25, P hat is 0.10.
Yeah, so I think on this one, it's just 0.10. And then magically in cells I123 and 124, it gives you both possibilities.
Right.
And in the column G, let's see.
Well, but what do you P hat is normally distribute requirement. So all right, so the formula in D123, it's P or P hat. but it's different depending on what you put in. So how do you know what to put in there?
Well, you know what? I think the formula is the same as far as the cells go. As far as the calculation goes in the calculator, the numbers are different, but the actual formula is the same with the exception of either P or P hat.
Okay.
So if I recall,
so the question's true. The requirements have been met because it's either greater than or equal to 10 for both of them.
I've inputted the tenth and the quarter, and on both of them, it's greater than 10. It's equal to, or rather, it's equal to or greater than 10.
Okay.
So true on that one.
Okay. The requirements for conducting a hypothesis test are satisfied. Go back to.
And I think that's the same formula, but if you have some notes.
Yeah, I think that's the same one, right?
Yeah, you know what?
Yeah, the hypothesis test is the same thing. NP greater than 10, or N times 1 minus P is greater than 10. So it's the same.
Yeah, you know, believe it or not, there is a difference between a confidence interval and a hypothesis test. One of them, and I think I only know this because I got ahead today because I'm going out of town for work this weekend. And there is actually a difference between a confidence interval and a hypothesis test when you're doing that equation. One you use P, the other one you use P hat, and I don't remember which is which.
Yeah, you're right. Yeah.
For the hypothesis, it's P.
Okay, is that what it is? Yeah.
Right, and then for the CI, it's P hat.
Okay. Okay, good.
So that one also is the requirements for connecting. They are also true.
I believe that is correct.
Okay.
Nikki, we opened up the Excel spreadsheet I just sent called Formulas and Calculators?
I haven't gotten it yet.
What?
Oh, because I got mine.
You got yours?
So it's crazyforflips88 at gmail.com.
Yeah.
Where you sent it, Ed?
Yeah. That is where I sent it to everybody in the group.
Yeah. Crazy number 4 flips.
I don't think James needs this stuff because James seems pretty sharp. Crazyforflips88 at gmail.com. That is so strange because you're just right down the street from me, Nikki. And
that doesn't really make a difference.
And Joe is all the way in New York. Well, I wonder, should I try to send it again?
I'm going to forward the one you sent me.
Oh,
okay.
That helps.
Maybe your pipeline is more direct to the 909 area code.
Okay, so it was sent.
Oh, there we go.
Okay.
Okay, good.
Which one do we have open? The 3?
Right.
Number 4.
Right now, the one that says 404 Formulas and Calculators.
Okay.
I didn't send the one that says 104 and 204 because that's just the QIP and the QDS from the previous, or the QDA from the previous 2 units.
Okay.
And there's really nothing on those that's special.
Okay.
Okay. So, a study of first-degree murder trials, was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. So there were 60 people on trial, 45 were found guilty. Find P hat, the point estimator of the proportion of first-degree murder defendants who are found guilty in this state.
So that's where you take 45 divided by 60, right?
Correct.
So it's 0.75.
That's what I've got.
Yeah, that's what I have.
Okay. 95% confidence interval for the true proportion of first-degree murder trials in this state. In this state there, the verdict is guilty. There's a typo in there. Input your answers for the margin of error, lower bound and upper bound. So I'm assuming we can go to your spreadsheet for this.
Okay, yeah, let's go to the QDA hat spreadsheet. In fact, let's go back and input the numbers for that first proportion. So let's see. X was 45, N was 60. And by the way, at cell E12, that 0.750 comes up as well. So maybe we'll just do all the rest on that on this.
You're down in the p hat confidence interval one piece, right? Like around 137 to 140.
Oh no, yeah. Let's switch over to the one that says 304 categorical data and analysis hat.
Okay.
Which is the one that came from BYU Idaho, from Sister Lemon? One or the other? It says 3 or 4 categorical data analysis hat.
You can play outside.
Saying it's 95, so it's 1.96.
Are you still on the formulas and calculators, Joan? I think we should skip over to the other spreadsheet.
The categorical one, right?
Yeah, the category, because it looks like all the rest of these questions are going to be contained in 3 or 4 categorical data analysis hat.
And I just made my own little thing for the margin of error for that one.
Yeah, I actually did too. Based on Raylene saying that Sister Lemon had her put it in, that made a lot of sense to me, so I did it as well.
Yeah, that's what I did.
So we're putting in the inputs part. X is
the X is the X is the hits, the successes, the 45. Yeah, and then 60 is the sample size, the N.
Yeah, I got a margin error of 0.112.
I can't even find a margin of error.
And Joan, I just made my own cell for that, for the margin of error.
Oh.
I just did it right next to the confidence interval.
Well, there is something there that says MOE.
Yeah, I actually did that, Joan, as well. Now my confidence interval is 0.110. Actually, it's 4 digits. I probably could bring it down to 3.
Okay, well, I don't
wonder
have
why
that.
mine says 110 and Nikki's yours says 112.
Yeah, mine's 112201667.
All right, so in the input section, we have 45, 60, and then 0.95.
Correct.
Yeah.
Nothing in null hypothesis, and it doesn't really matter what it says for type of test.
Mm-hmm.
At this point, correct, yeah.
Okay, so then my confidence interval level, right? We're down, there's nothing in the p-value. There's nothing in the z-value.
There's not?
there's nothing in the, it just says like, gives you like a formula error.
Oh, shoot. I wonder if it made it to you corrupted.
In my Z, well, but I just sent it to Nikki and she's using it, right?
Yeah, that should be the one I sent you.
You're using your own, right, Nikki?
What's that?
You're using your own, correct?
Yeah. I sent Joan the copy of mine.
Yeah. Well, maybe Joan, try using Nikki's. I'm sorry about that.
Okay, so no, it's still, it shows it. No, my Z and P are still showing. All right.
Well, then in that case,
I'm going to share my screen for a second just to show you.
Okay.
Yeah. Oh, I see. At the tab on the bottom, it says 2 proportions.
Oh, we're in a 1 proportion. It just opened up to where it was.
Yeah,
okay.
Yeah, exactly. Okay, good.
That's what it did to me too when I first started using it, and I got really confused by it.
It's maddening.
Okay, so now does that look right? Confidence intervals of 6.640 and 0.860.
Yes.
Heavens.
What Ed? I inputted my N as 65 instead of 60, so that's where that you got.
Oh, okay.
I just said the wrong number.
Okay.
And then, all right, and then here's your margin of error you did over here. It's the 0.109.
Yeah. Okay. We are on the same page.
So would we do 0.109 or is it 0.1?
Well, we'll make it easier. Click on that cell.
Uh-huh.
And now go up to about 4 lines to where it says format cells. It's just right there. Scroll down to number. I think it's the second one. And then where it says decimal places, hit the arrow, go up to 3, and then OK.
0.110. Okay.
And then that should simplify it. You could go probably to maybe 4, but either 3 or 4, I think, is for all of our online.
Well, most of them they do ask it for 3, so.
Yeah.
All right, so I'll stop sharing. Okay, so what the heck is the question? Determine the margin of error for this 95. So that's the 0.10.
Yeah.
0.110, yeah.
And the lower bound is 0.640.
That is what I have.
And the upper bound is just trying to 860. Okay.
That is what I have.
If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? So if you increase the sample size, you decrease the width.
That is correct. The bell curve gets closer.
I just know that there's other people around that can correct me. I know what I'm talking about, but I have no confidence, I guess. So if I know that there's other people that kind of have my back and to say, no, it's this way, I know
exactly what you mean. It's frustrating. When I test by myself, I have mini panic attacks at pretty much every question.
Right?
Yeah.
That's how I am too.
Yeah.
Yeah, I couldn't believe how well I did on the last.
Yeah, you did wonderful.
Yeah, brava.
I could not. Yeah, but by divine intervention is how it happened.
Well, yes.
To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals a half. What is the smallest number that can be? What is the smallest N can be? Sorry, N can be, and both requirements still be met.
Okay. Now on this one, this was a little bit complicated, but I was able to put it into a formula. And if you go to the spreadsheet that says 404 formulas and calculators, I'll talk you through the formula.
Okay.
So you can, write it down or do it on your calculator in case. By the way, that's why I like the calculator, and I don't use the spreadsheet for my exams and quizzes because of the corruption issue that happened. I never quite trust these. Okay, so let me find the.
So it's the sample size calculator, right?
Yeah. Okay. Go to cell 140 or row 149.
49. Okay. 0.5. So what's the calculation for that? Oh, the 10. That's right. So
Yeah.
that's 10 divided. Okay.
Yeah. That's exactly what it is. It's kind of the inverse of, well, okay, not scratch all the inverse of it. It's 10 divided by the
Population.
The population,
Yeah, the half, the 0.5.
Okay, that makes sense.
So before we move on, let's just say we had a P of 1/3. That would be 0.333 going on for eternity. So in this, just for simplicity's sake, to help you get your head wrapped around this, if you put that in the cell, 0.333, hit enter, then you'll see that the two numbers there.
Uh-huh.
The top number is if your P is less than a half or less than 0.5.
Oh.
And the cell directly below that is if the P is greater than a half or 0.5. They're two different formulas.
Oh, okay, so you do the 1 minus if it's greater than 1/2.
Yeah, in fact, directly above that is the formula within that purple square. It says if P is less than half, solve N equals 10 divided by P. Then it says if P is greater than half, solve N equals 10 divided by parentheses 1 minus P close parentheses.
Okay.
So that's the distinction. If the P is higher than 50% or lower than 50%, you use a different calculation. And this calculation comes in handy later on for confidence intervals and hypothesis tests and a couple different things. It's almost identical.
Okay.
So it's kind of a good formula to know. Good formula to have in your notes probably for the next exam or something.
Yeah, that's great. Thank you for explaining that.
Yeah.
Oh well, let's do one at 0.75 in that cell. Just for kicks. Since 0.75 is higher than 0.5, use the bottom number, which is 40.
Okay.
Got it. Okay. So, but the actual number is 0.5, right? So the answer for the question is 20.
Yeah, answer for the question is 20.
And then the next one will be the P equals 1 out of 10. So P equals 0.1, which is 100, right?
That is correct.
Okay. So
Do you see that, Joan, how we changed that cell to 0.1?
no.
It's the same formula.
Mm-hmm.
The only difference is for the previous question, P was 1/2, or
So now it's just 0.10.
one hit for every 2 sample sizes, a 1 to 2 proportion. For 12, the proportion is 1 to 10.
Right.
So in that exact same formula we were just talking about in cell C149, if you put in 10%, 0.10 or 0.1
Right.
or a tenth, but in decimals, 0.1, I'm sorry, 0.1, then automatically, if you follow that row over, it says n equals
Right. So it's 100.
It's 100, yeah. Which seems like a big sample size, doesn't it?
It does. Well, okay. So use the following information for the next 6 questions. For the water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect the water quality in the area has decreased. They conduct a hypothesis testing using significance level. Standard deviation of 0.05, not standard deviation, significance of 0.05 with the following hypothesis. So the null is 0.06 and the alternative is less than 0.06. They collect new data this time with 80 numbers and 38 indicate good health. So the conditions for conducting a hypothesis test are satisfied. So again, it has to be that n 1 minus n, right?
Actually,
No.
since you have your QDA hat open already, X is 38. You have that in the violet cell, correct?
Yeah, I just filled out all that information.
Yeah, that's what I started to do as well. Even though the numbers are not that related, it's easy. I just put them all in at once. So X is 38. You had that. That was the hits or the successes. The number of the sample was 80. The confidence level, and this is all according to the data in the paragraph on the quiz for the question here. Confidence level is with an alpha of 0.5. That means that the confidence level is 0.95 because there's an inverse relationship there. And then the null hypothesis, as it says here in the question, is 0.6. And then as you see on the question, the alternate hypothesis is, the question is P less than 0.6? So in the type of test on the violet cell on the Excel spreadsheet, click on less than.
Ed, I'm so sorry. Where are you?
Oh, okay. Let's go back to I was going back. I know. I'm sorry. I was going back and forth between the quiz and the spreadsheet.
So we're still on a 1 sample test for proportion, right?
No, we're on the Excel spreadsheet that says
the 4 or 4. Okay.
Yeah, 3 of 4.
3 of 4 or 4 of 4?
Now we're on 3 of 4.
See, this is this is.
It's a little bit maddening.
You could use a 1 sample Z test as well. So either one, I think.
Yeah.
Could.
Okay.
The grade as I scanned the rest of these, because I did the test already, most of the rest of the questions are on that spreadsheet that QDA hat.
Yep. Okay. So one test. All right.
So go to the violet cells, and I'll just read the data directly from the question. Okay. For the water quality study in the reading, about 60% of the microvertebrate water quality indicators have historically been associated with good health. First clue, that 60%, that's the P, which is also going to end up being our null hypothesis. But that's our working P. That's our working null hypothesis. Okay?
Mm-hmm.
So you could put that in the hypothesis. And then I'll continue after you have that.
I'm sorry. I'm sorry. I was doing something else. I'm sorry. I'm putting.
Do not feel bad. You're on a single screen, aren't you?
Yes.
Yeah. No, I know. That's why just keep it on the spreadsheet and I'll just read. Are you on the spreadsheet now, Joan?
Yes.
Okay, good. So then based on just that one sentence, we learned that the P is 0.60, and at the exact same time, it's the null hypothesis. So on your spreadsheet in the violet cell to the right of the words null hypothesis, put in 0.60.
Right. Okay. Yep. No, that's in there.
Okay, so I'll read the next line. You stay focused on the spreadsheet, and I'll just read the next line. The researchers suspect that water quality in the area has decreased. So there's a hint that we're going towards a less than.
Yep.
Okay. So we could might as well now below that where it says type of test.
Yeah, less than.
Put less than, yeah. Then the next sentence says they conduct a hypothesis test using a significance level of alpha 0.05. Now, if you remember from like unit 1 or 2, probably unit 1, an alpha is directly it's related to the confidence level. So an alpha of 0.5 gives us a confidence level of 0.95. So in confidence level cell, put 0.95. In fact, I think the formula is alpha is confidence level -1, or maybe it's the other way. Maybe confidence level is alpha -1. but basically it's an inversely related.
Right.
Okay.
No, I remember.
Okay, yeah, okay, good. And then I would continue with that sentence. With the following hypotheses, it says HO, but we knew this already, HO colon P equals 0.6, and we have that already on the spreadsheet. HA is P is less than 0.6, and we have that already in the purple cell. So the next sentence, they collect new data, and this time N equals 80. So go ahead and put 80 in your N box. And that's the sample number. And X equals 38. And that's the number of hits, or the number of successes.
So that goes in the X box.
Correct.
Yeah.
So X38, N80, confidence level 0.95, null hypothesis 0.60, type of test less than. So everything else, at least for the top half here, is pretty much ready to go.
Right.
That's all of our data, like our
everything else from there.
Yes, they're all that stuff.
So after all that nonsense, what's the actual question?
Okay, good. Question 13. The conditions for conducting a hypothesis test are satisfied. Now, if you look in column, there's two different types of requirements. One says hypothesis test requirements, and then a little bit below that it says confidence interval requirements.
Yep.
Those are two different tests.
Right.
This question is asking specifically about a hypothesis test. So that's E4 and F4.
Right. So if it says greater, but E4 is, I have zeros.
Oh, how is that possible?
Oh, I don't know. And then for F4, I have 60.
Well, we zigged when we should have zagged somewhere. It came up on mine, and Nikki, it probably came up on yours, right?
Yeah. Here,
So In the inputs, I have 45, 60. Oh, I don't have the 0.60 in the null hypothesis. So it's 36 and 24.
No, let's see. Let's go back to the purple cells real quick.
Joan, I just snipped my Excel thing and then sent you a picture of it. That way it might be easier. I don't know if you got it.
Oh. Or you know what? Duh. Why don't I share my screen? That was lame of me.
So it's yeah. So I don't know why I had 45 in there instead of 38.
Oh, you know what? That was from the old one. So probably that's what happened.
So it's 38, 60, 95.60.
38 and 80, right?
What the heck is wrong with me?
Yeah, 38 and 80 for those ones.
So it's 48 and 32 are the numbers.
Yes.
Correct. And you see that. By the way, I'm sharing my screen, so my screen should look exactly like your screen. Oh, but you're a one display anyway. So
okay, I can click on you and I can see it. Okay.
Okay.
I'm just a mess.
So back to the question 13. The conditions for a hypothesis test are satisfied according to the E4 and F4. 48 and 32 are greater to or equal than 10, so that's true.
Yep.
Question 14. Are we caught up, Joan?
Yep.
Okay. What is p hat?
So that's the 0.475.
That's
Yeah.
it.
And then the test statistic, is that the z-score, right?
That's the z-score.
Yep, 1.334.
Yep, that's what I got.
Oh, wait a second.
What'd you get?
1.334. No.
Oh, yeah, you have a different one.
Why is mine different?
Oh.
Okay.
Wait a minute.
One thing I do know is it has to be on the negative side of the normal probability applet because we're working with a less than. So what did you say you had, Nikki and Joan?
1.334.
Yeah.
Okay, so I'm just going to make a guess that it at least needs to be a negative. The z-score at least has to be a negative. I'm not sure. Let me write that down. What did you say you got?
1.334.
But you know what? If you click on that, though, like if I click on that, it just has that number in there. It doesn't have a formula like it has for everything else.
Oh, what the heck? You're right.
So I wonder.
Okay.
Oh.
What's the click on that and just read off what the formula is, Ed.
I just did, yeah. So you could input it.
So what did you? Are you still sharing your screen?
Yeah.
So it's. And I'm going to be a brat, and I'm going to ask you to read it to me because I have to go back and forth.
I got you. You are not a brat. Okay. So start out with equal sign, then left parentheses.
Yep.
E12 minus $, C $, 7.
Wait. Minus $, C 7. E12 $, C7.
Yes, close parentheses, divided by G12, and then enter. And I can read it again if we have to.
Negative 2.282.
Yep.
Okay. Hallelujah, sister.
I must have erased the formula somehow.
Yeah.
Before I set you down. Sorry.
That's why I just clicked on it to see, and I'm like, well, wait, why is it just a number and not a formula? Because it should be a formula.
Yeah.
Negative 2.282.
And it's funny. Every time I use these, not every time, but often enough, I do that same thing. I'll want to clear data, and I'll simultaneously clear the formula. And by the way, that's one reason I use my hand calculator for the exams and the tests, because I don't have enough confidence in myself.
Well, and that's just it. Like, I would have been like, oh, the answer is 1.334, and that's what I would have put on the test. So
yeah. Okay, so 15, find the test statistic. That's the Z, and we determined it's negative 2.282.
That's what we decided.
Question 16, what is the p-value for this test? And that's in the next cell over.
0.11.
Correct. 17, what is the decision for this test? I will forever to my deathbed remember jingle. If the P is low, reject the HO.
No, if the P is low, keep the HO. And if the P is high, reject the guy.
If the P is low, reject HO.
Right.
Okay. Did I say it? See, then I'm already messing up Sister Lemon's limerick jingle.
So
okay, so the p-value.
The level of significance was 0.5, and this is 0.01.
Yeah.
We're going to reject because it's lower than the level of significance.
Correct.
And then number 18, that would be the fourth one down. There is sufficient evidence to conclude that the water quality in the area has decreased, right?
Yes.
Because you're reiterating the...
So if you're rejecting, you have sufficient evidence.
Yeah.
Correct.
If you're failing to reject, because what you're rejecting is, okay, got it. There is sufficient evidence to conclude that the water quality in the area has decreased, which makes sense because it's only 0.1, whatever.
Right.
I get it.
Hey, do you want to review any of these questions and or answers and or formulas before I submit?
No, I think like I've kind of clicked on every cell now, and there's a formula in every cell, so I feel comfortable.
Okay.
I do feel comfortable with that. I mean, we can go through real quick if we want to go through the answers just to make sure.
Okay.
So 3 is the P hat.
No, 3 is just P.
Oh, and I asked that before. Yeah, because it's the true population, right?
Correct.
Word true but see, true and proportion kind of threw me off. So the true population is P, and then sample size population proportion is the P hat.
Yeah, it kind of throws me off too. The the X bar, the P hat, those all have to do with data points more than a population.
Awesome.
So
4 is true.
Wait, number 3 was a P, right? It was just P?
Correct. Yep.
Just P. Okay.
Just P. 4 is true. 5 is true.
Yes.
6 is 0.75.
Yeah.
Ish.
7 is
round to 3 decimals, 0.750, just in case.
Oh, it does say 3. Yeah.
Okay. 7 is 0.110.
Mm-hmm.
Yes.
8 is 0.640.
Yippers.
9 is 0.860.
Yish.
Yeah.
10 is decrease.
Yish.
11 is 20.
Correct.
12 is 100.
Yes.
13 is true.
Yes.
14 is 0.475.
Yes.
15 is negative 2.282.
Yes.
16 is 0.011.
Yes.
17 is reject.
Yes.
18 is there is sufficient evidence to conclude the water quality in the area has decreased.
Yes. Okay.
Ready.
I will submit, just in case there's an erroneous answer, we can hash it out.
Yep.
And hey, 19 out of 19. We did great. Man, we are a good trio.
You guys are great. Thank you so much for putting up with my nonsense.
Oh, it's not nonsense at all. Do you want to talk about anything else? Should we stop the quiz to spare Sister Lemon our yap about our final project?
Yeah.